Hi all, it's great to have you at our second chapter of Polkadot India Substrate Saturday Bootcamp. That's a highly competitive Rust and Substrate training series within the country. A very big welcome to you all, especially as the very first batch of cohort that's going to be doing this and getting placed into some of the biggest Polkadot projects or global projects in the Polkadot ecosystem. So congratulations on picking up this promising technology at such an early stage. And we're all with you through your journey. So just keep it interactive and we shall make things as good for you as possible. Now, please note for all those of you who have already not joined our Discord channel, we have an exclusive one for developers only. So do get in touch with the team, or we keep sharing the Discord link often. So join in, because that's where all the interaction happens with regard to the Substrate Saturday Bootcamp, as well as your assignments that are going on. So share your views, share your knowledge, participate in the assignments. Don't shy away, because we're all learning together. And we have also shared an assignment already, the second one that is, and we have a Q&A schedule next Friday with your trainers. So that's going to help you sort out all your queries and doubts, if any. So do join in and get clear, because now things are going to get really in depth, right? We're going to go further into the course. Now, so why we are here today is this amazing Polkadot project. So from an idea to a global product, and now a community of like 60K, 70K plus in less than a year. Learn all about thriving to exchange. Now that's Polkadex for you. And currently IDOs are inefficient, costly, and they're time consuming. So this is what Polkadex is solving, because they are fully on chain, they're transparent, they're inexpensive, they are fair, and there are no gas wars. So this is a simple explanation of why Polka IDOs will be a big game changer in the world of launchpads. And today we have a genius senior Rust engineer of this star Polkadot project, and to give us some crucial insights on extending substrate functionality with custom palette. So guys, let's welcome Ivan Temchenko to guide us right. Ivan, welcome, and it's an absolute honor to have you with us today. And over to you to just take us forward.
Yeah, thanks for intro, and thanks for having me today. Hello, everyone. I'm Ivan Temchenko, and as said, I'm a senior Rust engineer with Polkadex. Let me share my screen. I hope you can see it.
Yes, you can see it now.
Great. So, again, a workshop on extending substrate functionality with custom palettes. What we will do today is we will look into what substrate frame system is, generic overview. We will look into ecosystem of the palettes, how you can extend a blockchain or runtime using those palettes, how you integrate those palettes, and then if we will have more time, we will look into the palette itself, what it consists of, and how you can implement your own palettes. And at the end, I guess we will, if we will have time, we will have like a global AMA session, so you can ask me anything then. But when we go through the slides and code, please raise a hand in Zoom, and we can have it like interactive. So I don't want to do like a dry talking all the time, and then you will forget some questions you might have and not ask them at the end, something important to you. So don't be shy, raise your hand, and I will try to catch that up and answer. But during the presentation, please try to keep on the subject. Yeah. After the workshop, if we have time, we can talk about anything substrate related, not just the palettes, anything you may want to ask. So we won't be diving into deep technical details. This will be a beginner entry-level workshop to give you an opportunity to have a hands-on experience on actually integrating actual palette into actual runtime. For that, we will use our Polkadex node. We won't be configuring the runtime and all that stuff. That takes quite a bit of a time. So not doing that today. We will use our pre-configured node for that. And we will use one of the existing substrate palettes, and we will integrate it all together. We will also touch on basics of the blockchain and basics of Substrate. Again, no deep dives today. Obviously, we will talk about Rust, how Substrate utilizes most powerful things Rust can provide. And code of conduct, again, slides plus code. Ask as we go, don't hesitate. Any questions before we go?
You guys can drop a question in the chat or raise your hands. We can unmute you.
Okay, if no one has any questions at this stage, let's talk about Substrate and the frame system it introduces. So what Substrate is in general, again, it's a framework to build blockchains. But what is different? What is different with Substrate? What it makes it special or makes it stand out to other blockchains, which are, let's say, more popular right now, but yeah, Substrate is getting there. So Substrate has a 4-class updates, and what it means is that whenever you have a need to extend your blockchain with some functionality, make some changes to how storage is being laid out, add something or remove something, you don't have to restart a full chain from Genesis block from zero. You can update your runtime version, update the WebAssembly you're building, and continue with whatever you already had. This is not the case for most popular blockchains, and this makes Substrate really unique. Additional thing is that Substrate is written in Rust, and as I said, it does a really good job utilizing most powerful things Rust can provide, such as traits. And for those who are not familiar, traits is basically Rust way of defining programming interfaces, but those traits or those generics are, let's say, free for the runtime because they all are being substituted with the concrete types during the compilation. And we will take a look into that when we look through our palette as we go, how it is implemented. And talking about what is frame system. So frame system is basically the set of the modules you can build into your runtime. And those modules are included and built into that exact piece, which then can be updated without forking the chain. So it's on this diagram, it's in the middle frame system. To run the actual runtime, you need either the node or you integrate it into Parachain. But anyways, we are talking about this middle part today, and yeah, so let's get to it. Any questions right now? If anyone can monitor the raise hand, because Zoom on Linux is not great.
Sure. They are monitoring it, no worries.
Yeah, if there are any questions, let me know.
Sure.
So what we will do today is we will integrate pallete assets into our Polkadex node. So why we do that? Why we want to do that? Let's say we have a blockchain and we want to bring some foreign assets, NFTs, some ERC tokens, whatever you want, you can create your own. But for that, we need a management for such tokens. And we could do that in one way by implementing everything from scratch, which would take time, and we would have to do audit. We would have to make sure that we don't have any issues with our implementation, or we can take something which community already built and use that. And that's exactly what we will do today. We are reusing the existing piece of code for this, and we will do it in two ways. So first way is you can follow up with me using your computer, clone the repositories step by step, follow what I'm doing, or you can clone the final repo, because obviously I already did this to prepare. And you can clone existing one, build it and run it, and yeah, see how it performs. It's up to you. So yeah, if you want to follow up step by step, please do so. If you don't, you can go to GitHub. I will share this link in a sec. And you can just clone anyway, everyone will have to clone it. Whoever wants to also have hands-on experience for this. So this is the repository. If only I could find the chat in the Zoom.
Can we share the link in chat?
Yeah, I'm trying to find where is the chat in the Zoom. I haven't used Zoom in a while.
It's already shared, Ivan. Yeah.
Okay, great. So you can clone that repo and then cd into that folder and just switch to existing branch, which already have everything implemented. If you want to follow up step by step, you also need to clone that repo. And we also need a substrate from Parity. We need one of the templates which are included with the repo. It's quite big, so it may take a while to clone. Yeah, and then we will copy that existing assets palette into our node. We will look into how we integrate this with our runtime after this is done. So if you're interested, please do so right now. So let me share my terminal. So if you follow up step by step, you don't need to switch the branch. Just use our mainnet branch, that's fine.
Ivan, I think you're on mute, so we can't hear you.
Yeah, I know. I'm just sipping some coffee.
Sure.
Still early a day for me. Okay, so I'm not gonna clone the substrate repo. I already have that cloned. So I'll just copy the palette after Polkadex repo is cloned. Okay, so for me, it's done. We can start coding. So let me go here. Let me share my ID. I hope you can see it. So let's quickly talk about what we have as a components here. So first, we have this palettes folder, and this is where we put our palettes. It's not necessarily should be called palettes, but it's easy to find and understand what it's about. Runtime is obviously our runtime, which is compiled to Wasm. This is the part which is upgradable. And there is also another important one, which is called node. And this node contains the configuration for the runner of our blockchain node.
Ivan, sorry to hold you, but people are finding it hard to read through the editor. Can you just zoom in a bit? It becomes easier for them.
Yeah, give me 1 second. Is it better? Should be better.
Yes,
Yeah,
yes.
it's much better. Yeah.
Thank you.
Yeah. So again, palettes is where we put our modules for our runtime, and then we integrate everything into Node. So let's take a look what our freshly copied assets is. Let's take a README. Let me a second. I will bump the font of the editor too. So there is a description of the palette. And as I said, we could implement this by hand and we can reuse. So I encourage everyone to reuse stuff from the community because usually it's very robust, optimized, and implemented in a way that it is safe to use. I will touch on that a bit later, but now let's take a look what we have in this example. So we have some imports here, and we have our annotation that we have our palette declared here. There is a palette example GitHub repository, which contains an example palette, but unfortunately that one has so-called Substrate 1 annotation, where instead of these annotations, everything is built on macroses, and Substrate moved from that, and now we have just annotations for our modules and components. So let's talk about this a bit. So we have our module, which is called palette. We have some imports here as well. That's not that important. The main thing is from import side is that when we build our palette, it consumes a lot from what the frame system provides for us. This is required mainly for storage, for configuration, and for all those traits I was talking about before to have them imported, and for those annotation macroses as well. All those traits, not all, but some of them are required to be implemented. Some of them can be emitted, such as events. Your palette not necessarily want to emit events. Your palette not necessarily needs a storage. It might, but it's not forced to. You can have different types of extrinsics, such as unsigned extrinsics, which we don't have in this palette. That's a more advanced stuff. And this integration we are doing right now is explicit integration. We could also include it implicitly. I will talk about this later when we look into our runtime, how that is implemented and how it uses different palettes, even though we don't have them in our project directly. But right now, what we have here is the configuration for our palette. And this configuration is that, again, it's a trait. So basically it's an interface, which we, let's say, have a child configuration traits as boundaries for it. So those boundaries are basically, we are saying that to configure this palette for the runtime, we will have to configure the frame system configuration trait and assets configuration. And we will look into how we can do this from the runtime perspective, because this is how our palette understands what we want from it to do. Because we say some, let's say, ephemeric, some phantom data stuff here, but we need to it actually, for it to actually work, we need to say which concrete types we will use for our token identifiers, for types of our tokens, what size of the data they will be, and stuff like that. So this is a README. Let's take a look into exact code. Let's take a look on the dependencies first. So we have the name of the palette here. This is important because we will use this name to integrate it into our runtime. We have dependencies. Codec is the way of encoding data. It is also implemented by Parity. It's really efficient. And this is how, like, everything which is being stored on the storage or transmitted through RPC or WebSockets is encoded into bytes using this codec implementation. Scale info is additional module for codec to work, for our types to be properly identified, how to encode, decode them. And then we have some substrate dependencies. Substrate STD is re-implementation of some Rust standard library, like vector or other types or collections. We have our runtime, which provides us integration, and we have our frame support and frame system. These two provide us those beautiful macroses and those traits and everything we need to actually implement and integrate it later to the runtime. We have benchmarking, which I will briefly touch later, but we are not implementing this today. This is needed to generate the weights for our extrinsics. So basically how much one would have to pay to call some function on our palette. Yeah, and this is just a name. And these are dev dependencies. So dev dependencies usually used for testing or for benchmarking if needed. And important part that as our runtime is WebAssembly, it cannot be built with most of the standard library. As I said, there is a re-implementation of the portion of it. But for different purposes, we might want our palettes built with standard library included. So we have additional feature gates here for STD. All the palettes and all other modules or crates have the same feature. Same goes for benchmarks. And we have try runtime, which is not important for today. Let's take a look again into library. How our palette is implemented. So besides our configuration, we have declared here that we will emit some events, and we need to know which type of those events will be, and this type is associated type for our config. This will come from the runtime. We will see it later. We are declaring associated type. So associated types is another way to say that when you want to actually use it, provide me a concrete type from the Rust side. And here we are providing some boundaries. So this balance, which we will declare on the runtime, should implement all those traits. Yeah, it should be default copy, serialized, encoded, and so forth. Same goes for asset ID. As I said, we are working with assets, and we need to have some concrete type for those assets eventually, and we have boundaries for that asset ID here. We have currency, which is also used later in the extrinsic. We will take a look into that. So at this stage, everything from here is part of the configuration which we will define on our runtime. So why it's good? Why not just say that asset ID is always U64 or U128? Because people may have different needs for their implementation. Someone wants to have maybe, I don't know, U8, maybe there are only 255 assets they want to manage. So maybe you want to reuse this palette the same time, different configurations in the same chain. That's also possible. We have few associated types. No, this is a storage. So we have a storage and we store something in the blocks. There are three main types stored in the storage: storage value, storage map, and storage double map, which are most common. Here we have a storage map. It's pretty much as a regular map. You have some ID and you have some value. Here we store our asset ID and we store our asset details, which consists of our actual data. And here we have double map. Double map gives us a way to, so it's basically double key map. So we have asset ID, account ID, and our data here. Some other storage values, I won't go through all of them. We have our Genesis configuration. You may want to include some data on the get-go from the first block or from the first time your palette is spinned up on the current chain, but not necessarily. This is for STD feature. We are setting all those Genesis config values to empty vectors here, which for those who don't know Rust may look a bit weird with this default. So default is another trait, and we say that all those properties implement this default value, and they should provide that default value here. For vector, it's empty vector usually. And we have some Genesis build. Again, this is for first block or initial start of our palette, how it will build our storage, what it will insert. There is a function code. So again, this is a bit advanced, so I will skip to actual extrinsics. We have event emission here. We declare our event, which we will pass the type on the runtime, but we create events here, which will be actually emitted by our palette. So whenever we create a set, we emit this event, which we can see in Polkadot UI, or any client who connects to our blockchain can see this. Events are not being stored in the blocks, so it is quite safe to use them. You don't blotter your blockchain with emitting events, and pretty much every extrinsic emits some events here. There might be some error events. It depends on the implementation, and we declare which events we will emit here. Also, we implement the error for our palette. What errors can be emitted, like balance too low, there is no account, you have no permission to do that, and so on. And here we have the actual implementation of our extrinsics. So extrinsics is the substrate name for, let's call them contracts for how your palette or your runtime exposes your palette's functionality. So this is very similar to how you would consume, let's say, Ethereum contract calls. Yeah? And we define here the name of our extrinsic, and above it, we define that weight. And those weights are usually generated on some standard machine, standard configuration of the hardware. So you can have more or less accurate weights of how much CPU resources this concrete extrinsic will use. Usually it includes storage reads and writes, not just the CPU, because storage is very important for blockchains. Substrate, as most, if not all blockchains, is not constant size. So yeah, this is very important. You need to look out for not cluttering your storage too much. And the implementation of the extrinsic goes in this function implementation. The important thing is, for each extrinsic, you need to follow a simple rule: verify first, write last. What does that mean? It means that whenever you have some extrinsic implementation, you need to verify all the inputs, verify all the calculations, and only then do the storage modification. Again, the same reason, because storage operations are not cheap, and storage itself, well, you don't want to have a massive blocks and massive blockchains without a concrete reason for that. So what we have here, this is a function which is quite common for all signed extrinsics. Pretty much you will see this, unless it's a pseudo or governance calls. This function will check the origin, which is always the first parameter of the extrinsic. So whoever signs this from submitting this extrinsic needs to be verified that it's signed properly by the owner. And then you do some operations here. So we check for admin, we ensure, and this ensure macros makes sure. So it's quite similar to assert macroses. Whenever we need to make sure that our inputs are correct, we will see this ensure used. And then we do our operation and do our storage, right? And when everything is completed, we emit event. Yeah. Events usually emitted at the end because events doesn't have any impact on the storage. And we have a lot of more here, but we went through all the components, main components. So again, you need configuration, you need extrinsics, you may need storage, most likely you will, and you may have events. They are not mandatory, but they are cheap and basically costless, but good way to indicate that something happened to your users and to your UI if you have some specific UI for your blockchain. So most likely you will use them as well. Okay, any questions about the palette layout? I don't see any raised hands, so let's continue with the integration. Can you see my slides? Do I need to reshare? Oh. I assume you do. So let's go to our runtime and we will add our palette to our runtime to consume. Theoretically, we can add them wherever we want in the section of dependencies. I prefer to have them all sorted. So we have our local dependencies here, and I will say palette assets, and we have a path to it. And I will say default features false. So now we included our palette into our runtime, but we need to add some more modifications to this file. First, we will add them to our std. Something is wrong. I did some typos. Yep.
False.
Okay. Still not happy. Double checking the name. Palette assets looks good. Should have used that branch which already compiles. Okay, palette assets. I know what's the problem. Probably I haven't switched the branch for my. Yeah, one important thing I forgot to mention is that Substrate has a versioning. And this versioning comes in form of branches on the Substrate repository. So what we are looking for, we need to make sure that our palettes are following the same versioning of the Substrate as our runtime. And our runtime is currently locked to branch, which is called Polkadot 0919. So let's do that. This will take ages. Okay, that should be fine. Let me go back. Okay, let's take a look if that helps. No. I did something here. No.
Ivan, in the Cargodot terminal for assets, I believe palette balances also is used, and palette balances is not there in the palettes folder. Can you just cross check that one?
Yes, yes.
Can you? Yeah. I believe, yeah, that is the dependency that's missing.
Yes, so we need
Palette
we need
balances.
to replace all of that. This is something I forgot. So again, as we are copying the palette, we need to make sure that our target for our source is the same branch. So I will just gonna go into runtime, and I'm gonna just copy any of those passes. I'll copy this whole thing, and we will go here. And we will replace all the substrate dependencies with our path. Close this. And let's do the same for dev dependencies, just in case. Let's delete those leftovers. Okay, so let's also double check our scale info and our codec versions are matching our runtime. Codec 3.0 and scale info 2.01. Yeah, looks good. Okay. Let's see if our wallet is building now. Well, something missing. It's not right. So it was here. Should be good here as well. Let's check. Yeah, looks good. So let's also include it into our benchmarks. And try runtime. Okay, so we have included our palette as a module into our runtime, but that's not all we need to do. We also need to declare all those good things for the configuration, the concrete types. So as shown here on the slides, it's a bit of a copy-paste piece. What we are configuring here, we are declaring some types. This parameter types macro allows us to declare what exact values we are going to use as some types as substitutes. For example, this asset deposit is a type of a balance which equals to $100. And then we will use this declared constant from this macros in our asset deposits type, associated type on our palette assets configuration. So this is quite a bit of code. I'm just gonna copy paste it. I don't know if I want to copy paste it into chat. For those who follow up with us.
Hi, Ivan. Your slides are not shared. You can see your terminal.
Okay, give me a second. I will reshare. Can you see them now?
Yes. No, it's visible.
Okay, great.
Thank you.
No worries. Okay, let me copy paste this. So important thing is that this portion of the code should be included before we declare our runtime. There is a declare runtime macro. I will show you in a second in the code. Let me first copy paste this piece. And then we will talk about how we declare our palette to the construct runtime call and how we assign the ID for our palette. Can you see my IDs? Okay, can you see my IDE?
Yes.
So I've copy pasted this piece, which declares the configuration for our palette. But besides the configuration, we also need to include it into our construct runtime macro call. So let's do that. I will call it just assets. We will say that it's palette assets, palette, and then we will use palette from it, storage, call, event, and configuration. So here we declare that our runtime should include all that stuff from our assets palette under assets ID, and we need to assign the ID number. Right now we have a 33 here as the highest, I think. So I will say that it's 34. Okay, we also have the portions for declaring extrinsics, not extrinsics, but benchmarks here below. We won't do that. This is benchmarking is the topic for additional workshop. As I said, those benchmarks are used to generate the weights for your palette. So you basically implement the worst case scenario, and then you include that, and you run the specific command, which was changed recently without the documentation change. But anyways, you include it here, and then whenever you build your node using the Substrate benchmarks feature, you can run that command and generate those benchmarks for your palette. And that will be included into this macro. We are not doing that today, so let's check if it all builds. So one of the things you may find a bit frustrating is how Rust compiles stuff, and on some older machines it may take 30-40 minutes to do the build of the entire node. But yeah, it is what it is. Something is not included. Let me check. Yes, we need to add our assets configuration. Let me share my slides again. So we have also our node, as I said, and that node needs to have our assets config included. And this is for our Genesis configuration part. So the one which is being invoked whenever we create the fresh instance. So for that, we need to declare our assets configuration. It's done in the chain spec in our node, and then you add those assets configuration into Genesis config. I will leave this here for anyone who follows, and I will just copy paste it into my code myself. So again, in the node CRC chain spec, you import it from the runtime, from node Polkadex runtime, and you add it to the Genesis config of the testnet.
Ivan, you're on the slide screen. In case
Yeah,
you're
yeah,
showing a screen.
I leave the slide screen for anyone who wants to follow up and copy this while I'm copying to my code, and we will run it afterwards and look how it looks like from web wallet.
Yeah, sure. So I'll just give them a brief of what you're doing right now.
Yeah, I'm doing the same as shown on the slide, copy pasting this portion of code. So basically, as I said, it's a configuration for our Genesis block for the testnet from our nodes perspective. We are going to use it to run the developer build of our node with our runtime and our palette included.
Yeah, exactly. And to add on to that, guys, as you can see on the slide, there is a folder directory structure. The folder starts from node. There's a folder called node, where you store all your chain configuration. And inside node, it's again a cargo library. Inside source, you have multiple files, and the file that you need to update is chainspec.rs. And how do you do that is under something called as node Polkadex runtime. And you just copy paste the entire thing that he's showing to us on the slide on your chainspec.rs.
Exactly. Thank you. You can find all this code if you want to copy paste from the Polkadex GitHub repository. Just select the branch for workshop for today, and all this code is present there. Or as I said, you can just clone it and follow up just opening those files without needing to retype it. Okay, I hope everyone has done this, and I will just gonna reshare my IDE again. Let me share my entire screen. This will be easier. Okay. So for me, it checks out. Now let's run it in the dev setup. So what we need to do is we need to either build it first and then run the binary, or we can just say cargo run ---- So this first dash means that we pass our further commands or parameters to our binary, not to cargo itself. And also we can say tmp to have everything redirected to our temp directory. So I had almost everything built before. As I said, it's quite heavy, and for fresh build, it might take a few minutes. So let's wait for the node to finish building. Next, we will gonna connect to our node using the Polkadot web wallet, and we will inspect all those binaries and look how the interface which Polkadot provides us matches the implementation from our side on the palette side. So we compare the code to our not WebAssembly, but WebSocket provided API. Okay, so we have our node running on the default port, which is 127.0.0.1.99.44. And now I can switch the browser. And yeah, we have our dev node, and we will go to polkadot.js.org. What you need to do by default, you will land on live parachain of Polkadot. So you need to select on the top here the drop down, and then select development and local node, and that's it. So if it's running on default port 9944, you will get to your local node. We have a bunch of default test accounts here. We can make transfers and everything, but what we are actually interested in is extrinsics, which we've just exposed using our palette assets. To do that, we go to developer and select extrinsics here. And from this menu, we can select the palette. So we have all of these palettes. And this is the part I was talking before, that we can integrate palettes directly by having the code included as part of our repository, or we can integrate them by just adding the default from other repos. How to do that? Let's quickly take a look. Going back to our runtime. So here in palettes, we have two palettes right now. We have assets we've just copied, and we have migrations. And if we go to our runtime, in our cargo file, we can see the whole set of palettes. Election provider, babe, grandpa, those two are the consensus and block generating palettes. We have a bunch of standard stuff, and all of those palettes are included not from local repository or not local folder, local module. They are included from Substrate repository here. And we use, again, as I said, the same version of the branch. This is very important. If you miss this, and if, like, for example, I would say that this branch needs to be master, I would get some bunch of nasty errors. I will stop my node for a sec and I will try to cargo check. Yeah, already there is some conflict with the versioning, and this is really ambiguous. It says that your palette has some dependency which is not matching the other dependencies, and you may want to start digging what's going on, who has this dependency, how to upgrade this sync rate so it will match. A bit misleading. So again, make sure that you're following the same versioning and everything will be fine. So let me restart. Right now, I will start from the build binary, not to rebuild. So we have target debug and we have Polkadex node. I will just say dev and tmp. I don't need double dash here because I'm starting the exact binary, not through cargo. And our node is starting. We could do the same for our palette assets, not just copying the code. We could declare the same way as we did before. Copy paste this line, change the name to palette assets as it lives in the same repository, and then modify our runtime librs. Here, by adding the same configuration for the palette as we do for other palettes. Yeah. So we have, for example, we have palette recovery here. We have some parameter types declared here for it. On top with the parameter types macro, we then declare that for this runtime, our palette's configuration will consume those concrete types. Yeah. And we could do the same for palette assets. And I encourage you to do so because it really speeds up your development. And again, most of those palettes are verified by community, improved and aligned with the implementation of the runtime and of the node. And there is a big variety of those palettes, which we'll discuss a bit later as well. So now let's take a look at our palette we've just integrated. So we search for our assets, and we have a whole set of extrinsics exposed here. It's quite a big one. It allows us to do a lot of stuff, but let's, for example, take a look at some which you will use if you're consuming this palette. Is called force create. So it has some parameters here, accounts, and we would like to align it with what we have on our code side. So let's do that. I will try to bump this. That's too big. Okay, this should do. Can you see the browser okay? I hope yes.
Yes.
Okay, so going back to our librs, I'm gonna hold this. And going down to our extrinsics, I can just say force create to find it. So here it is. So let's compare what's happening on the extrinsics UI side, which is WebAssembly call, not WebAssembly, sorry, a WebSocket call to our code implementation. So first, we have our origin. So this is the signer, and this signer will be the account which is on the top. So use the selected account. It's the one which will sign this transaction for us. And this one will be verified here. Next, we have some, the name, and then we have ID. And this ID is matching exactly this part, which is the, should be of the type of asset ID we've declared on the runtime. Let me close some stuff here so we can take a look where this actually happening. Let's find our assets, and we are looking for asset ID. So here we are declaring that our palette assets configuration, which is this T generic, and we take this asset ID. And we say that this asset ID is a concrete U128. And this is exactly what we have here, U128. So if I would to change this to U64 here, recompile this, and reload the UI, we would see U64 for this parameter. We don't need to change the palette. We don't need to change anything on this side. It's implemented as it is. We just need to configure it and tell it what it needs to use. And so if you would like to use this palette assets in different way, we can easily do that. Same goes for this balance, for any flexible, let's say, generic parameter. Same goes for this portion. This is just a Boolean, so nothing to change here. Again, our UI presents us with yes or no option, and minimal balance, which is allowed for this new asset we are creating. It's also U128, and it says compact, which is also defined by this annotation. Yeah, so this is quite straightforward. We check that origin is correct, basically the signature. We are assigning the owner of this asset as the account which is creating it, basically this one. And then we force create the new asset with the new ID, new owner, and with all the other inputs. Any questions at this point?
Ivan, just a request. I think most of them might have missed certain aspects of how to add a palette to runtime. That was what was taught, right? As a brief. Could you just simplify it for them? Just run it through them once as a very brief explanation. Maybe that would help them probably figure out what you have done so far.
Yes. So let me get back to my slides and let's talk through them again. So whenever we have our palette, we can either add it by local path, as it's done here, or we can add the palette remotely from repository or from Crates.io if it's published to Crates.io. Usually it's a repository because, as I said, of the versioning. So for that, you can add the Git reference or you add the path for local palettes. Then you declare all the features which you want for your palette to expose. Your palette not necessarily needs to expose the runtime benchmarks. Benchmarks may come as a file which is ready to be used. And we can take a look into that quickly for benchmarking, because if we go into our runtime and weights, here we have already built and measured weights for our some of our palettes. Yeah. So those files come here as a pre-built weights, and then on the runtime side, whenever we declare our weights for palette grandpa, we are loading them from our weights module, which is this folder, and then palette grandpa, which is this module file, and then this weight info, which is exactly this. Yeah. Another way is to have them included alongside the palettes, as we can see with our assets palette. The weights is included here. We can refer to it directly, and if we look into our declaration here, I don't have anything defined here, but we could do this. And I assume it's waiting forward. Yeah, it's just waiting for without any generics. Yeah, so you can refer to it in this way. So that's how you integrate weights. One of two of the ways. And then going back to slides, when you integrated your palette into runtime, you also need to add it to the library for declaring it as a part of the runtime. For that, you declare some, you may, but you doesn't need to if you don't use any of those constants. And these parameters basically can be declared so your configuration can consume it as shown. Yeah, we take a look at the asset ID, how you can modify it and how it reflects on actual inputs your palette will take. This will also impact your calculations, because on the palette side, you will use some mathematics to measure the balances. So basically, whatever type it is here, it usually is limited if it needs to be. Let's take a look. Let me close this stuff. So for example, if we do some addition or subtraction, destroy, let's take a look into this domain function. Yeah, so here is the saturating add happening. Why is this important? Because saturating allows you not to underflow or overflow. So basically, whenever you hit your highest value, it will stay there. It won't overflow, and so it won't underflow as well. And you don't want any of that happening, obviously, on your blockchain. So you use saturated arithmetics for that. And after you are finished with this part, you've integrated all your types into your configuration. You also need to add that palette as part of actual runtime by declaring all the modules your runtime will use from your palette. We use construct runtime macro here. We say that our palette assets exposes palette, call, storage, event, and config to our runtime. And we say that it will have ID 34. And after that is done, to integrate with Node for our debug testnet Genesis. And Genesis is basically the initial values. So the first block in Substrate is called Genesis block. And whenever you start the dev chain, you have random generated Genesis block for you. And you can include some default values if you need for your testing. You can say that I already have those assets and declare them in this vector. Same goes for some metadata. So metadata is the description for those assets from palette assets side. And some accounts, if you want, you can also include here. And after doing this, you build your node and you can see that your palette is integrated. Yep.
Amazing, Ivan. That was a very nice explanation. Guys, is that clear for all of you?
Could you repeat?
No, I said that was a really great explanation for all of us to briefly understand what is the steps to add a palette to run.
Yeah, so again, there is, I encourage everyone to reuse whatever community is building. There is an effort from Substrate, which is called Substrate Market. And this Substrate Market, it was announced on latest Polkadot Decoded. It's quite fresh. Let me just click that link. Can I? Yeah, so you can find not just the palettes here, but some clients and some runtimes, because Substrate is configurable. So it's not necessarily that you forced to use one runtime or one set of palettes. This is the effort from Parity to collect all those community-built palettes and runtimes and nodes and clients into one place, so it will be easy to discover and to find. But for now, as I said, it's quite fresh. So if you go to GitHub and you search for this stuff, and then if you go into on the Substrate, if you go into frame, you will see a big set of the palettes which come with the Substrate itself. So there are different consensus palettes, different asset managing palettes, different utility palettes. For example, the timestamp is a very crucial one, because from the palette perspective, as it's a WebAssembly runtime, you cannot have the access to your system's clock directly. And this timestamp helps a lot if you need to have some measurements done on your palette side time-wise. For example, you have some limitations how often some function can be called by one account. Yeah, so for that, you would use timestamp, and whenever it is called, you will check your storage for existence of that stored value for that account, that yes, that account did that using this timestamp. And then you can do calculation how much time has passed since then, and either allow or reject that transaction. There is a sudo, which is good for testing. So basically you can have a sudo account, and it works basically for anyone who knows how Unix sudo works. Yeah, so a great collection of the stuff here. I suggest everyone to take a look before implementing stuff from zero. It's not the only place where you can find that. There is a lot of repositories which have the Substrate palettes implemented for various purposes, like bridging, asset conversions, and stuff like that. Just make a search, not necessarily on GitHub. Some of them are on GitLab repositories. I saw one even on the how you call it? I forgot, but never mind. Just Google whatever you need. Another great resource for any Substrate developer is Substrate IO and docs. So this is like Substrate is really still a young project. A lot of changes is happening constantly, and the most accurate documentation is either on the GitHub itself or here. Yeah, we already looked into this portion, and there is advanced topics. There are tutorials how to do stuff. You can go through all of this. Yeah. And one more thing I want to share is that there is Stock Exchange Substrate, which recently got spinned up. There was a voting, community voting. We voted for it, and it was created. And there are already, it's really active, and there are already big number of answered questions, common and really complex ones. So I also encourage you to use this. Search for the answers to your questions here. If you have any problems, if you don't find anything, just ask, and community will help you find the answer to it. Any questions?
Ivan, I do have a question. This is regarding benchmarks, but is this a time to ask, or you want to do it during the questionnaire?
No. Let's do AMA, I guess.
Cool.
So yeah, go
So
ahead.
yeah, so the thing is, when we write benchmarkings, right? So there's a issue where every time you rerun your benchmarks, the value that comes up is always varying, right? It is not constant. Why is this? Do you face this, or is it normal to have this issue?
So again, benchmarks are not deterministic usually. How benchmarking is happening is that you try to predict the worst case scenario which may happen with your extrinsic.
Yes.
For example, if you have a parameter which can be different in size, not a constant size input, that may impact severely how your benchmark will work, right? Because it can use different size of the storage, it can use different CPU time for that. It can impact other functions being called. So you try to predict the worst case scenario. And then when you run your benchmark, you try to use the same hardware, as I said. There is a recommendation, or let's say whatever VM Parity is using for benchmarking their pallets. And they even have, I think, the t-shirt name, which you can get from AWS for that. And then using that machine, you run your benchmark, but you run it several times. Yeah. And whenever you execute your benchmark, you have the parameters that please run this benchmark like 20 times or 200 times. And then you get the average or the worst case scenario again. So it may vary, it may depend on the load of the system. So it's not deterministic. And that's expected, and yeah, that's just something we all live with.
Thank you, thank you. Yeah, because we were just running our in-house projects at Wow Labs, and we are not sure if this is a. I mean, we understand that this is behavior is normal, but I just wanted to check: have you faced the same kind of issues? And for those of you who don't understand what benchmarking is the process that Substrate framework allows your developers to figure out what the transaction fees. Ethereum has something called as gas fees. That is the similar concept as what transaction fees is in Substrate. So to calculate the transaction fees for every extrinsic, what do you mean by extrinsic? Extrinsics are functions that can be callable by an end user on the blockchain, right? So to calculate that, we use a method called benchmarking, where you write. So previously, if you had seen, he had shown you the benchmark macro, right? Benchmark is a normal macro. It's not an attribute macro. It's a normal macro that lets you calculate how much is the transaction fee. So yeah.
Yeah, so here we have a benchmarking for our palette assets, which is included. We have here the macro declaration for our benchmarking. If we name our benchmark function the same name as extrinsic, we don't need to rename it as we call. We can use underscore here. This part is the setup part, how we set up our benchmark, all the inputs. And then here where our benchmark is actually happening, this part, our benchmark is being called here, and only this part is being measured, not this one. So don't be afraid, because sometimes there is misunderstanding and people think that preparations are also part of the measurement, but no, this should not be impacting you by any means. You can do whatever expensive calculation you want here to set it up. And then only this line where you call your extrinsic is better. And then you verify that, yes, your extrinsic succeeded, and then it will be measured. When you implemented everything, you just build the same way. You just say cargo build features runtime benchmarks, and this should work. I'm not sure because I didn't include my assets here, so who knows? But anyways, you build this like this, and then you will have your binary, which is built for runtime benchmarking, and you can run those benchmarks with the different inputs. You can benchmark only one specific palette, or you can benchmark only specific extrinsic if you want, or you can benchmark all the stuff. You specify how many runs you want to see and where to put the outputs of your benchmarking into which file. And then you will have those weights values generated for you. Okay, any other questions?
Thank you.
Yeah, so I don't think I have all the required features added, but yeah, anyways, that's benchmarking.
Okay, I think we are good. Any more questions, guys? You can always drop in with those further. But thanks, Ivan. This was great. And I'm sure we'll have many more questions coming in where we'll surely approach you further, for all the help with it. And this not just took us through all the planned agenda of working with custom palettes, but it's also opened up doors for so much more. So we wish you all the luck from all of us out here in India. And looking forward to a lot more from Polkadex and you. We'll definitely stay in touch, especially with the questions from this session. Guys, we'll definitely be sharing a recording, so you can always go through it over and over again and come up with your questions, and we'll forward it to Ivan so that he can get back to us with it, and we'll get back to you with it. So yeah, drop in your questions on the Menti link that you already have, or that's shared in the chat box, and we can get it sorted for you at the earliest. And we shall see you all next Saturday at the third session of the Substrate Saturday Bootcamp with your trainers. That's Lokesh and Tejas, who have been helping out very wonderfully this evening too. So do not miss the Q&A session on Friday the 29th to help you move along with your assignments. And thank you all for making time this weekend on a Saturday evening. And thanks for your dedication toward this program. And we definitely have great hopes from all of you. So have a great evening ahead, guys. And Ivan, so glad to have had you this evening with us. Thank you so much.
Yeah, it was my pleasure. Thank you. And just want to mention that my colleague Faisal will gonna do the workshop on palette testing in 2 weeks, I think. So yeah, everyone, don't miss it.
Yeah, absolutely. Yes, we do have Faisal coming in as well from the Polkadex team soon. So like you all know, we have these expert guest sessions as a part of the bootcamp session, and Polkadex is one of the projects that will be recruiting from the bunch of you guys if you get ahead of the assignments and do a good job out of it. So yeah, looking forward to Faisal's session too, and looking forward to a lot more from Polkadex, and hope we give you some good developers, Ivan.
Yeah, looking forward to all of that, and thanks everyone for participating and for your questions. Have a nice rest of your day.
Yeah, thanks, Ivan. Have a great evening, guys. And one question, like we would love to have your input on how your experience was. So all of you, you can feel free to like put in your comments in the chat box of what you thought of today's session. Anything you have to say at all about this particular ascent, right? Great. Have a great evening, guys, and have a great weekend ahead too. And we shall see you next Friday for the Q&A and next Saturday for the Substrate Saturday Bootcamp. Yeah.